Hello, welcome to our first ever live online lesson, and today I'll be solving this question which I assigned to the year 10 chemistry class. We are learning about the limiting and excess reagents. Alright, so this is the question. Copper chloride reacts with sodium nitrate to produce copper nitrate and sodium chloride. So the first thing you need to do is to write a balanced equation. So that's your equation, but it's not balanced, right? So let's do the balancing. That should do the trick. So now you have a balanced equation. Alright, so now we move on. You have 15 grams of copper chloride and you have 20 grams of sodium nitrate. So you need to understand that in any chemical reaction, at the end of the day, very likely you will have the products and one of the unreacted excess reactants. You need to understand that. And in this exercise, we are going to find out which is the excess and which is the reactant that limits the reaction from progressing further. Alright? So, for copper chloride and sodium nitrate. Okay, so you have to know the ratio is 1 to 2 based on the moles from the balanced equation. And we have 15 grams of copper chloride and 20 grams of sodium nitrate. So now you got to move away from saying the one in excess is sodium nitrate because it's more than copper chloride. Like 20 grams is more than 15 grams. You can't say that. We need to find the moles. Alright? So, yeah. So the moles present. So what we need to do is to find the moles. So we take 15 divided by the molar mass. So 6471. That would be 135. So the amount of moles present in copper chloride is 0.111. We'll do the same thing for sodium nitrate. 20 divided by 23 is 85. And the moles present for sodium nitrate is 0.235. So these are the moles that we have. Okay. So now if you take for copper chloride, okay, the moles present is 0.111. Alright, remember this one is the ratio of 1, and sodium nitrate, the ratio is 2. So if we were to react all of the moles of copper chloride, how many moles of sodium nitrate do we need? Right? So we would need 0.222 moles. But do we have that amount? Do we have that? Well, we have 0.235 moles of sodium nitrate. So do we have enough? Yes, we have enough. Alright, we have enough. And we have more than enough. We need 0.222 and we have 0.235. So there is an excess. So immediately we know that sodium nitrate is in excess. But how much in excess? We take 0.235 minus 0.222 and we have an excess of 0.013 moles of sodium nitrate. Alright. Now if we want to react all of the sodium nitrate 0.235, how many moles of copper chloride do we need? We would need 0.1175. Do we have enough? No, we do not have, because we only have 0.111 moles. So immediately you know that these are the number of moles that did not react. Alright? So, how many moles of copper chloride reacted? We know from here it's 0.111 moles. How many moles of sodium nitrate reacted? 0.222. And out of the 0.235, you need to understand that there is 0.013 that's not reacted, that will be left together with the products at the end of the day. Alright, now let's just move forward from there. How many moles of copper nitrate? 0.111. And how many moles of sodium nitrate? So we just follow the ratio, 0.222. Alright, now, so what is the limiting reagent here for number 2? It is, so now we know that the excess is sodium nitrate, so the limiting reagent will be copper chloride. So that's copper chloride. Number 4, how much of the non-limiting reagent is left over in this reaction? The next question states, yeah. So, yeah. So we know the amount in moles, but very likely the question wants the answer in mass. So what is the mass of sodium nitrate that's left over? So you take the moles times the molar mass, which is 0.013 times the molar mass of sodium nitrate, 23 plus 14 plus 48. So what would that give you? So the molar mass is 85, and you multiply that with the number of moles. So you will have 1.105 grams of sodium nitrate left together with the products, which is copper nitrate and sodium chloride at the end of the day. Now moving on. Okay, the last question. If 11.3 grams of sodium chloride are formed in the reaction described in problem number 2, right? What is the percentage yield of this reaction? So firstly, we need to know the theoretical mass. We need to know the theoretical mass of sodium chloride. Okay, and just to refresh your memory, sodium chloride, the theoretical mass is, we take the moles, which is 0.222 times sodium chloride's molar mass, which is 23, plus 35.5. Alright, so 23 plus 35.5, okay, we get 58.5, and you multiply that with 0.222. Now, theoretical mass would stand at 12.987, but they only managed an 11.3. Alright, so the percentage yield would be 11.3 over 12.987 times 100, and that would give you 87%. Now that is how you complete this limiting and excess reactant question. Thank you.